Good morning, everybody. This is Tim. Hope you all doing well today. Today is the 29th of October, 2025. We had a historic landfall yesterday in Jamaica, um, and catastrophic. It was terrible to watch, and we'll know more later at first light how much damage there is. All right, and but I would if you look here, you can see where it made landfall with the track between Black River, Sandy Ground, White House, and Jamaica, along to the right of it. I'm sure there's pretty much nothing left because at landfall at 185 mile per hour, sustained with gusts over 200 miles per hour. So anybody that was still there, hopefully they're in a shelter that could stand that much. And you can see the track here, how weird it was leading up to landfall. Um, Crazy how it all evolved, right? So now it's over Cuba, and it's a 125-mile hurricane. And this is the advisory 2 a.m. And I'll pull up the 5 a.m. advisory towards the end of the video, and we can look at that. Hopefully, we'll have that before I stop recording here. Uh, Going back to the satellite, obviously heavy rain ongoing right now for a lot of eastern Cuba. I don't have I'm zooming in here. All of eastern Cuba, parts of a good portion of eastern Cuba is getting in on it right now. Likely the sustained winds are a bit lower right now, but it's moving faster to the north here. So its forward motion will contribute to the winds on the right hand side here as well to some degree, right? But and also its forward motion is faster, so it likely won't weaken quite as much as it did when it went over Jamaica because it took longer. But um, looking back at this, northeast at 10, it's still not that fast, but it's faster than it was. So again, match the same winds, 125s of his 2 a.m. here. So for a little context here, and this is not official, this is what I've asked a Google DeepMind to pull up for me. Melissa, comparison peak intensity anywhere in the Atlantic. Hurricane Melissa, pressure wise, tied for third for pressure. Wind speed tied for second, 185 mile per hour. A record dry eye temperature, um, which means the eye was extremely stable. And that may be something will be that will be something I'm sure that's will be researched and will come out in the final report for this system. But I would argue that in this case, that may be why it was able to keep intensifying like it did. And from a hurricane perspective, the dryness in the eye is due to sinking air and compression, right? So as air sinks and compresses, um, uh, it dries out, and that's what happens in the eye of a hurricane. Okay, you have the eye getting smaller in terms of size. You have sinking air. All right, and that's part of the cyclones evolution. Okay, And of course, this isn't a final report. I just want to show you this for reference. Strongest landfalling hurricanes. Tied for number one. As with, this is unofficial, okay, guys? Hurricane Melissa. Strongest landfall by pressure. Tied with a Labor Day hurricane. And that is saying something because that's held a record for, you can see here, 90 years. Strongest landfall by wind speed. Melissa. Labor Day. Dorian. All at 185 miles per hour. And this is unofficial. It may be analyzed upward or downward later. Irma and Janet. Okay, so what we witnessed yesterday was historic. All right, and from a meteorology perspective, excuse me, it's interesting, but from a human toll, it's humbling, sobering, and catastrophic. And I hope people in Jamaica are. They're, I'm sure they're no stranger to tropical systems, but this was a whole different thing, and I hope that people were prepared and loss of life was minimized because they had plenty of warning all along the coast to prepare. So I hope they did. So what's the future? One second here. I want to show you this too. This is the so I can get this to play. This should be. This is the radar from Guantanamo Bay, the Navy facility there. This is I'm trying to see the time. I don't know if this is I don't think they are on the time. Um they change time, so it it doesn't look that current though. Okay. This is I think that's 0500Z. It may the radar may have gotten knocked out. um But you can see the eye of Melissa as it moved towards Cuba, and it's kind of covering up the all the precipitation's covering up the island. But there it is, guys. I'm sure it's devastating as well. More from the wind, the rain and the storm surge, okay, than the winds, but still, okay. Going back to the radar, I mean the infrared, okay. This is the cone of uncertainty. All right. I'm going to stop this for now so it's not distracting. Um, you see right here. This is, see if I can move this down. October 29th, 8 p.m. So it's forecast to be the cone of uncertainty between these two lines here. Let's take this off. Okay. Um, Between Acklands and the middle of Clarencetown, with the center of the cone going in between. So that's 8 p.m. today. Okay. Forecast to be roughly category 2 at that point. All right. And we move through this. We have still a category 2 hurricane with gusts of 121 miles per hour. All right. And then tomorrow, 8 p.m., very close to Bermuda at this point. And The cone of uncertainty or direct landfall is to the north of it right now. Well, no, it's over it, but the center of the cone of uncertainty, which isn't the impact cone, okay? Other people say this too. My friend Mitch West says it all the time. I'm going to say it. Um, this is the uncertainty in the track here. So it could track straight over Bermuda, could track this far, or it could track in the middle, it could track anywhere in there. All right. So that's what the cone of uncertainty is for. Um, Now it takes it pretty close to Newfoundland, right? And it wants to have it a tropical storm even up here, which I'd have to. I'm gonna look at the models and see um, what it looks like there, and I'll show you that in a few minutes. But this is the cone of uncertainty from National Hurricane Center. Um, so I I'll show you the super ensembles next from the Berg website. All right, this is another way to look at the cone. All right, way down here. All right, Bermuda is somewhere up in here. You can't really see it. So category 5, 3, 2, moving over the out of the warmer waters into cooler waters here. Um, so we're getting into 25 with the marginal waters for tropical cyclone, which I would say that probably going to be um, get becoming extra tropical or taking on some of those characteristics up in this area. And so that's another way to look at that. All right. This is issued at 03 UTC. All right. This was 11 p.m. So we'll have another one. See if we have it. We can refresh this. Nothing yet. All right. Model intensity, of course, is going to drop off. You can see here where it's starting out, and not likely to intensify much. Maybe a little bit as it moves back over open water. So we'll have to take a look at that, but not nearly what it was. Okay. So there's another graphic that shows the initialization and the um, how the tracks have moved in reference to where it was initialized, and you can see they've kind of moved up to the left a little bit, and Newfoundland may be in on this too. We'll just have to see where the center comes on shore. And this the grand ensemble, which shows quite a bit of spread this far out, but overall the spread is nothing like it was when Melissa was down here. And I forgot to bring up my pen, so let's do that. Can't believe I did that. But how come nobody told me? Come on, guys. Anyway, um, there's Bermuda. There's Newfoundland. Unlikely to make a direct landfall here, although the um, uh, effects might still be felt there as the wind field spreads out, right? So, and I'll go through the global models on this part, but so that's that. I hesitate to go over too many other model guidance except for maybe going over the global models and show what it's going to look like further out here. So that's what I'm going to do now. And let's pull up the GFS here. Hey, we all love the GFS, don't we? I think it does a lot better with systems that are already formed than genesis, guys. It really struggled on this one. Let me see if I can zoom in at all here. There we go. Okay. See if I can get today lowest. All right. The total accumulated precip. All right. So along on this path here, you can potentially have 12, 14, 16 inches of rain. And it moves faster, of course. You can see where it is. All right. So um, let's look at the wave heights real quick. That can't be underestimated here, especially you can see that where the wave heights are largest here on these islands that we talked about. Splitting the crosshairs between these two along to the right of this thing, especially where it's going to be a problem. See how the waves spread out here. We're talking 20, 30-foot waves here. And so this can't be, oops, this can't be minimized here, right? Look at that. So that's important to look at as well. Okay, pressure and wind, the GFS. This is Thursday, October 30th. Let's back it up a little bit. This is valid overnight, tomorrow night. Wait, yeah. Tomorrow morning or tonight, excuse me, around I don't know, 10 p.m. or so Eastern time. Okay, roughly. Don't hold me to that, guys. Forecast to be a pretty category 2 or 3 hurricane here. Still pretty symmetric. Going to the north. Has it going just to the north as far as direct landfall goes, the center, okay? But again, reminder that the cone is encompasses that whole area. All right, so I would probably let me just look at the hurricane model real quick, like the Hasse parent. Maybe that'll give me a better idea here. What's going on? Let's see how far out we can go. It comes precariously close to Bermuda here. Hey, Bermuda. I'm going to turn off this here so we can circle this. Okay, guys. I know this is taking a little time. Bear with me here. Oh, it doesn't stay there. Great. um. Anyway, you can see Bermuda there. Likely going to experience the strongest wind. You see how the winds are the strongest, possibly close to 100 miles an hour where it impacts Bermuda. Okay. Then swings up to the north here. Gets drawn into this other low pressure. But right now, from this model perspective, it doesn't look like it's going to directly impact Newfoundland. All right. So it looks like it's when it goes through this hurricane model, when it goes through the straits here between these two islands, it's going to be pretty symmetric. So you likely experience pretty strong winds when it comes through here, guys. So, yeah. So that's just one model representation of it. Let's look at the European real quick. Zoom out. Okay, European, roughly the same scenario, although where it gets closest to these islands is very important for the strongest winds. So there's still a little wiggle room here, but the models are in pretty good agreement here. Now we get to the Bermuda. This one, the European is further to the left. If we zoom out here, North Atlantic, see what it does. It wants to come very close to Newfoundland, but again, the strongest winds are on its eastern side. So although the pressure gradient is going to be pretty strong here, so yeah, it they may issue tropical storm warnings, watches up here, or some kind of wind warning as this moves up there. So that'd be wild if we had another landfall of a tropical system up here. That would be 5. If it landfalls on Bermuda and there, that'd be something. I'm going to switch back. All right, so here's a 5 a.m. Advisory from the National Hurricane Center. Promised I'd have this up here. And so, nice sustained wind down to 115, moving to the northeast at 12 miles per hour. You can see the cone here. Still, Bermuda is a hurricane watch, right? Forecast to be a tropical storm, post tropical up here by Newfoundland. Um, Devastating rain, of course, going on. Rainfall into Cuba right now, and going to be going over um, the Bahama Islands here that we talked about earlier during the day today, and then going past Bermuda um, Friday morning sometime, or just overnight on Friday. Okay, this time it'll be accelerating, so as far as total speed over water goes, like northeast. See how it's increased to 12 miles per hour. All right, so going on to the continental U.S. forecast, I've been neglecting this past couple days because of Melissa, so I'm going to try to do this real quickly. And for those of you to want to utilize the timestamps, this would be a good way to use them if you want to look at what's going on here in the continental U.S. Of course, you know what's going on in your area, but we've got some what we got going on here. We got some mid-level ridging going on right here with a trough. We got some ridging up in here, flow going like this. All right. With good look at the upper level water vapor loop. Shows basically the same thing, right? But um, forcing, especially along the Gulf Coast, and you see the highest moisture is. Okay. Look, switch to the long wave infrared. Mostly overrunning precip here to the north. Let me get that off the screen. All right, so convection like this along, looks like a frontal boundary moving through. And you got moisture going over top the flow here, which is, overrunning like this. Stratiform precip likely. And there was severe weather here yesterday. I'll go over those chances here in a minute. And we overlay that with radar. Take a look. Yeah, so that's what I'm talking about here. A lot of rainfall going on right now along the northwest, along the Gulf Coast, some stronger storms possibly here. So, what's the model data show? So this is the European. Let's get a more recent. Let's go. It's starting at 8 a.m. See the mid-level low here. Another one up here in the northeast. high pressure up here that I showed you, and a high pressure here. The low churns, and then we have, excuse me, sorry guys, they kind of merge here. Sorry. And then we have Melissa right off to the east here, kind of getting caught up on that flow. Not kind of, it is. You see the broad northwesterly flow here. We switch to 925 millibars, which is in the lower levels. You see the northwesterly flow here. Okay, as that low shifts out, switching back to 500 millibars. This is a good indication of the steering flow. So where you have this mid-level region, it's going to be likely warmer temps and cooler temps in this area here. That low spins off the east coast, northeast, well, in the northeast. We have some more mid-level perturbations moving through the flow here. You can see this low, this kink in the flow here, right? Um, Going like this. See if this becomes negatively tilted or not. Uh, okay, going through the flow here, you see kind of a split flow here. Yeah, so you have the stronger jet stream winds to the north. You have a split flow to the south here. This is not cut off totally from the flow, but it does get cut off eventually. See, it's not even part of the jet stream flow. So you have this split flow here, and then never really phases with the jet stream. So we have, excuse me, surface cyclogenesis. If we go back, we're starting at 8 p.m. here. There's our surface low. There's Melissa. Low moves up. It's a inland rider here, so no chances of snow on this one, right? Potentially some heavy rainfall here or severe weather. Let's take a look real quick at one of the soundings. I'm talking way too much here. Yeah, too cool. Sorry, guys. All right. Whew. All right. So surface low, Melissa. This is the European model, which is arguably the most reliable model out there, global model. Okay. So what I'm showing here, you see some frozen precip up here in Canada. You see these 534, 540 line. That's denoting the freezing line. That doesn't mean it's going to snow. That's just how it's denoted on the map. Okay, so don't take that as it's going to snow here. It doesn't necessarily mean that. Taught that in school, beat down into our heads a million times here. So you see what happens here. It's throwing over some precip into the colder air. Looks like a mix here. Maybe some snow up here in the northeast as that system moves away. You see what's happening here. You have that low that we showed here, going back to this 4 a.m. on the second. Go back. That low there. That progresses. Let's go to hour 144. Show where this is. Increased moisture flowing through here, more rainfall for the southeast, which is nice. Snow up into Canada, which I would expect this time of year. Okay. And so going through what happens here, we get surface cyclogenesis. We have that low here, and we're going out to our 144. See that? the low right there, rainfall again, overrunning precip here, going out to the 5th. You see how the low energy transfers offshore here, which is not uncommon along this um, temperature gradient between the colder, warmer waters and colder, warmer air. Okay, a low moves offshore, but because the jet stream is further to the north, these don't phase offshore here like you would get a nor'easter kind of thing, right? And kind of thing. But anyway, that's that. Then it develops finally, moves out to sea there. So, and you have onshore here on the northwest, which is not uncommon this time of year, of um, incessant systems going on the northwest. And you see maybe some mid-level region building in here. So I'm looking at temperatures. Let's look at that with the European. These are just actual temps for the nation, okay? 60s and 70s for highs at the most here. 40s. Getting kind of warm into Texas, but I mean, in the desert, southwest. Um, but overall, in the west, you have that high pressure building a little bit, right? That we showed. Highs in the 60s, 70s. Of course, building in a little bit more east of the Rockies. We get over time, we get out to this hour, 144, which is the third at 7 p.m., which is 4 or 5 days from now. See, the third is Monday. See, you can make out that low maybe there, right? Still highs, 50s, 70s, warming up again a little bit here after that system moves through. And you can maybe make out a cold front moving through the flow here, but warming up for a good portion of the nation. You get further out to the 9th, which is pretty far out, so that's going to stop it. As far as severe weather goes, this is going to be a long video. Sorry, guys. Let's take a look. Severe weather possible along the Atlantic coast today. Marginal risk, right? Likely. No tornadoes. Wind risk probably due to saturated downdrafts. Rain loaded. No hail expected. All right, for day 2. We still got severe weather expected on the with that system moving up to the north with that low pressure um, moving inland here. That moisture flow I was talking about, and you saw that um, line of storms moving through. That's probably what we're seeing here. Tornado risk minimal. Wind marginal. Hail no risk. Probabilistic, that means we can go to day 3. No severe weather expected. No thunderstorm expected, at least according to this, which I don't know about that. But day 4, day 5, day 6, day 7, day 8. All right. So excessive rainfall. Most moisture is expected here in the Appalachians to the upper Mississippi Valley, Ohio Valley today. Where you saw that rainfall, right? Moves further to the east, right along the Jersey coast, Long Island, into parts of Pennsylvania. All right. Same thing for the next day. So if it rains heavily in this same area, we could have a real problem here. Still centered on the northeast as that system moves up to the north here. So then along the northwest coast, we have um, a chance on day 5. So the most rainfall expected through the next 7 days along the northwest coast and into the northeast up into Atlantic Canada. All right. And along the path of where Melissa goes. Anyway, that's all I got for today, guys. Pray for Jamaica, and we'll talk to you tomorrow. God bless.